So we set up a confidence interval about the proportion of people we predicted trust the president. And we came up with the situation where we figured that 63.7 plus or minus 3% of the people trust the president. Now, we had a margin of error of 3% here that we calculated in this problem. Let's say we want to figure out, and we polled 1,000 people. Let's say we want to cut this margin of error in half. Then so we're going to make it more accurate. Well, then how many people should we now poll? Well, we can do something that we did before. We can use some algebra. We can look at our margin of error, and we can figure out. We can isolate. Well, let me go up here. If we look at this term here is our margin of error. So I'll make it magically appear here. So the margin of error for our proportion is this value represented here. And we can do the same thing we did before with our margin of error when we're dealing with trying to figure out the size of our sample. We can isolate and solve for n. And if we solve for n, we end up with the relationship flipped around a little bit. So it looks like this, p hat, q hat, and you can do this on your own. You can do this to verify z alpha over 2 for yourself. That this relationship is correct. So if this is the case, my margin of error in the problem above was 0.03. So half of 0.03 equals 0. Put an arrow here because that's not equal. 0.03 divided by 2, and that equals 0.015. So that's what our new margin of error is going to be. And all the rest of these values will stay the same in this relationship. So then n is going to equal 0.6. Oh, I forget the numbers. 0.637. And q is 0.373. Our z alpha was 1.96. And divided by our margin of error that we want to have here, which our new margin of error is 0.015. Square this. So we do that calculation, and I have it placed into this calculator here. So I did it here. 0.637 times 0.363, not 373 actually. 363 times 1.96 divided by 0.015 squared. I end up with 3947.9, so 3948. So this is approximately 3948. And I again corrected the number I wrote down incorrectly. So around 4,000. So now instead of 1,000, we would need to poll 4,000 people to reduce our margin of error to 0.015. So that's all I want to really say about confidence intervals concerning proportions. So the key thing here, though, is looking at your problem statement and determining that you're dealing with proportions and not with means. So you need to practice that a little bit. And while you're working on your homework, you will, towards the end of your homework, the proportion problems start. So that makes that a little easier to figure out that you've moved into proportions territory. So just as a summary, keep in mind that when we talk about a confidence interval about the population mean, we are using sample means and information in the sample mean to do that. If we know what sigma was, the population standard deviation, then we have one method to do that. If we don't know what sigma was, then we have another method using the sample standard deviation, another equation. On the other hand, if you read your problem statement and it looks like you're talking about situations where 50 out of 3,000 people have been inoculated for something, or 9 out of 10, well, that's pretty small, 90 out of 100 people wear black shoes to church, things like this. These are proportions, and problems like that, you need to use the equations we have set up here for proportions. And that's all I'm going to say, I guess.